Will multiple switches slow transfer speed? I want to create link between a data server, it's more like NAS, and around 300 computers. Data transferred per day is around 2 GB/computer, and speed really matters. If I use a single switch it with 300 Ethernet cables, and maybe too messy to maintain. If I use a switch on every 50 computers, would it slow down the connection speed?
Every extra step of switching is an extra delay. No matter how fast your core is, it's still processing. That said, at only 2 GB a day you won't notice it, and I'm sure that 300 port switches don't exist. Now if you were using hubs, that would be a very different story. Switches only send packets to the IP address tagged on the packet. Hubs bounce packets around every computer, and it's up to the computer to accept or reject. If you're really concerned about speed, you should look at making your data store as efficient as possible. If it only has a single gigabit connection, you'll always be limited there. 300 gigabit connections to 1 gigabit source equals trouble. Edit. I should add a solution to the issue I identify here. What I have done is build a computer with 2 Intel NICs, network interface cards, and enable the teaming feature. This enables the 2 cards to work as one, essentially creating a 2 gigabit network interface.
If with transfer speed you mean throughput, it should not matter much. Every extra device will introduce some minor latency. After all, some processing is needed, if it is only very minor. However, latency is not the same as throughput. Compare it with a conversation via a satellite phone. There will be a 3-second lag before someone else can comment on what you said, but if one person just keep talking, telling long, 2 GB stories, then the slowdown will be minimal. Which means that I would test these setups. Many switches have a connection which allows you to turn several separate units into one giant switch. That makes management much easier. Much sure that the switches you buy have this feature. Why 48 port switches? It limit the number of devices. Less space, less devices which can break down. Why 40 computers per 48 port switch? Future expandability, computers moving to different rooms, increasing local density, added devices such as printers, a free port for debugging, etc. etc. Why not a single 300 port switch? Good luck finding those. Edit. Apparently there are some. I looked up. The model mentioned by David, it is about $25K US. Use these kinds of switches if you absolutely need maximum performance. If you already have switches without an backplane link, you could always do something like this, but that would mean traffic would flow excessively to whatever switch hosts your file server. That might overload that switch, and will introduce much more latency than needed. The long roundabout cable is in case a switch dies. That would cut off all computers on it and to the side from the switch with the file server. In which case switches with spanning tree protocol can detect this and automatically enable the workaround link. Lastly, there is always the classical tiered setup. This one has the advantage that you have one, very good, switch in the server room, and at least one link from that switch to each floor or each section. Then you set up a local room with all the switches for that floor. If needed, with multiple switched, tied via a backlink.
If I use a switch on every 50 computers, would it slow down the connection speed? Your topology won't change the connection speed, but the effective throughput would be affected. Another consideration is the type of switches you install. An Ethernet switch can use either of 2 techniques for receiving and then transmitting the Ethernet frames. Store and forward, the entire frame is received and buffered before it is retransmitted, or cut through, aka wire speed, only the destination address has to be received and buffered before retransmission is initiated. For a full-length Ethernet frame of 1542 bytes and 100 base T, a store and forward switch would introduce a latency of about 123 microseconds, whereas a cut-through switch would introduce a latency of about 1.2 microseconds. For short frames, e.g. ARP packets and TCP ARCs, the difference is of course much smaller. As you add tiers of switches, you could be adding significant amounts of latency to the transmissions. Consider the case of one more layer than the ideal flat model of just one monster switch. For a full-length Ethernet frame of 1542 bytes and 100 base T, 3 store and forward switches would add latency of about 369 microseconds, whereas 3 cut-through switches would add latency of about 3.7 microseconds. If host_1 starts transmitting a full-length Ethernet frame of 1542 bytes at 100 base T with 3 store and forward switches in the path, then host_200 receives the last byte about 492 microseconds later, or that's an effective throughput of about 25 megabits per second, compared to the actual wire speed of 100 megabits per second. With 3 cut-through switches in the path, then host_200 receives the last byte about 127 microseconds later, or that's an effective throughput of about 97 megabits per second. If you want the best throughput possible, then you need to use as few switches as possible. One monster switch is ideal, and use cut-through switches to minimize the latency each switch introduces. Note that almost all low-cost switches are the slower, i.e. longer latency, store and forward variety.
If you want to support the channel, please consider liking and subscribing.